Hello friends, in this video let's analyze a problem involving dynamics of non-uniform circular motion. Let's read the problem. A car goes on a horizontal circular track of radius r. So we have been told that there is a track of radius r and there's a car going on this track. Its speed is increasing at a constant rate a. So the acceleration of the car is a in terms of its speed. This is not the acceleration vector, but this is the rate at which the tangential speed of the car is increasing. And we have also been told that the coefficient of friction between the track and the tires is mu. So these tires and the track underneath them, the coefficient of friction here is mu. We need to find the speed at which the car would skid. So because there is acceleration involved, the speed keeps increasing. And at some point, intuitively, we can tell that things would not hold and the car would skid. Given we have been given the radius of the circle, the coefficient of friction, and the acceleration, and we need to find the speed at which the skid would happen. So v skid is what needs to be found in terms of a, r, and mu. All right, let's work this out. Let's analyze the car. So here's the circle. Let's say this is the car. Let's say the mass of the car is m. Let's assume the mass is m. So there is a downward force on the car towards the ground, which is mg. The ground exerts a force on the car, normal reaction n. We are also told that there is a tangential acceleration involved. So the only other force that could act on this car is friction, right? So the forces on the car are mg, n, and friction. Now, because there is tangential acceleration involved, so there is some component of friction in tangential direction, which is imparting the acceleration a. And then because there is circular motion happening, so there is a force, there is centripetal force involved as well. So that is coming from friction in the radial direction. Okay. Now, in vertical direction, acceleration in vertical direction is 0, and hence n equals mg. So this is one result. This is easy. Let's look at tangential direction. Acceleration equals a. This is given. Therefore, force in tangential direction has to be ma. And the source of this force is friction. So frictional force in the tangential direction is ma. In radial direction, acceleration equals, instantaneous speed of the car squared upon r. Therefore, force in the radial direction has to be equal to mv squared upon r, where v is instantaneous speed. Note that v is always changing, but at any instant when the speed's value is v, then the radial direction acceleration would be v squared by r, and hence force in the radial direction, whose source would be friction, would be mv squared upon r. So now let's look at, so there are two components of friction. Now there is ft and there is fr. Both are perpendicular to each other because this is in the radial direction and this is in the tangential direction. So the resultant friction, the magnitude of resultant friction is square root of fr square plus ft square. Now normal reaction is mg. This we know from the analysis of vertical direction motion. Basically there is no acceleration there, so normal reaction is mg. And force of friction equals mu times n, mu times mg. Well, the force of friction, the maximum value of it is mu times mg. So because we are talking about the limit here, that is we want to find the situation where force of friction becomes really equal to mg, and the skid happens just beyond that. So this is the equality we need to look at. So this implies that square root of fr square plus ft square equals mu mg. Now fr is mv square upon r and ft is ma. Therefore fr square is m square v to the power 4 upon r square, and ft square will be m square a square, and this will be equal to mu square m square g square. M cancels out, which is great because m was not given to us as a thing in the expression of the problem. We had just assumed that the weight of the car is m. Now, so this implies that v to the power 4 upon r square plus a square equals mu square g square. Now this is great because everything here is precisely what we want. We were given r, which is the radius of the track. We were given a, which is the acceleration of the car, and we were given mu, and we know g because we are analyzing this in acceleration due to gravity situation, and we needed to find v. So this is super simple at this point. This implies that v equals mu square g square minus a square times r square to the power 1 by 4, and that is the answer. This is the speed at which skid would happen. V skid. Thank you.